Yeah. So should we advance and do the batch job now?
Uh,
I think that's what
yeah.
was next in the notes.
Yes. If we
So
didn't. Yeah. So let's do a batch job for this one.
yes, I'm.
Yes. So
So now in the batch job, we introduce you to what's called a Slurm script or shell script. So this is the first time we're going to make a new file on the cluster. And in this file, we will put the instructions to Slurm to say what resources are needed, and the instructions to our code to tell it what to run. And it will all look quite familiar with what we've done so far.
yeah.
So to edit a file on the cluster, we'll use the editor named Nano. So it's a really basic editor. It's not fancy at all, but it's simple to use. It tells you how to quit it from within the editor. And from what we can tell, it's on every cluster. So it's a good starting point. So we're calling it the new
Let's
shell scripts count 1 grams dot sh,
yeah. Let's call it like that. Yeah.
where the dot sh means it's a shell script. So Simo pushes enter and Nano opens. So the shell scripts always start with what we call a shebang line for like hash bang, with bang being exclamation mark, and it tells it this will be a bash script. So bin bash, bash is the shell that we're using. So it's the
And this is
script
basically
here.
like the kind of magic that is like you will always just write this how often, like when you start writing these scripts, you often get into the automation that you will always write the shebang.
Yeah.
This you can use different ones, but usually uh
Yeah.
it's
It's like
easier
some
to
magic
just
words.
yeah
You open
yeah
you're
the
making a
spell
new
with the
magic spell.
yeah
You give
yeah
the standard magic words at the beginning, and it's something that you copy from the cheat sheet every time you do it. So now we see the comment symbol and sbatch here. So this sbatch is an instruction for Slurm to read and do something here. And now we add the same options we did from the command line. So for example, we'll tell it that it needs memory 1 gigabyte and sbatch time equals 10 minutes. And we could add whatever else here. Okay.
and should we add then the thing that we want to run?
Yeah, so
Or do
now
we
we
want
get to the actual
other?
shell, and we'll enter what we, basically the same thing we typed ourselves there. So ngrams count.py, words, and then Gutenberg fiction. Actually, do you know the file name of the thing?
Yeah, it's below there, down
Fiction.
there.
Yeah, you can copy from
Yeah.
the note down below.
Should we try to 2 grams actually? Like now that I think of it, should we
Yeah,
do
let's
2 grams? Yeah. So if we add here, was it dash in?
let's see.
We
I
can
was
get 2 grams.
testing.
I think
Yes, dash
it's yes.
lowercase n.
So now we count word pairs, right? Like
Yes.
the how many word pairs we can get.
Mhm.
So let's save
Yeah.
this file and
Okay.
actually
And saving
uh
with Control X and then
yes.
pushing Y.
Yeah. And actually I'll rename it to 2 grams.sh.
Count. Mm-hmm.
That's so now it's yes, save under different name, yes. Because uh it's a better name for the file. So
Yeah.
so
Okay. And now we actually do the running. So this is
yes.
it. We run the command sbatch and we give it the script file. And with luck, there won't be any errors and it will start running.
Yeah. I'll try to be
Are you
fast
ready?
here. Yeah.
So Sima will push enter and immediately run Slurm
Yes.
history.
Managed it. No, it already
Actually, maybe
finished.
Slurm Q.
Yeah.
Yeah, so now this is sort of a wide thing
Yes.
here.
And maybe I'll
So
try to make it.
yeah, so there's several key Slurm commands that you will need to know. One Well, actually, so this Slurm is only available on our cluster. So
It's
on
I
other
think it's
clusters,
also on some other clusters. But
okay,
it's not part of the Slurm installation, but it's present in many clusters.
yeah.
Yeah.
I'm writing some stuff in the notes here. So
But you
sbatch,
can,
uh,
there's other commands like sq
yeah.
you can use as well.
But okay, so what's the general thing? We basically we made our food order and we handed it off to the manager. So the Slurm. And now Slurm has a queue of everything there. And when you type Slurm queue, that tells you what's queued. And we see the second command, now it's done running. So we can type the command slurm history and see the status of how it ran. So slurm history needs to be,
Yeah, bit wider.
it's
Still.
okay if it scrolls off the screen some. Yeah,
Yeah.
that's good.
Yeah.
So we see here in the history, there's 3 jobs with IDs that end in 10, 43, and 30. So it tells us the job name, and we see for the last one, it's count2grams.sh, so that's the file name we submitted. When it started running, it said it requested 1 gigabyte of memory, and it used 602 megabytes of memory. So 2 grams took a lot more memory to compute than 1 grams. That's good to know. It says it
Yeah, and
took
it took a bit
22
longer,
minutes
like
of CPU time, or 22
22
seconds of
seconds.
CPU
Yeah.
time. And towards the end, we see the state is comp, which means completed.
Yeah, and at the end we can also see what was the name of the computer, like the nodes where it ran. So you can see
Yeah.
that some of these other programs ran on this PE78 and this run on PE8. This is not usually important unless you run into problems or something, and then like if the computer breaks or something, and you need to contact us that hey, my code didn't work. But usually like the queue manager can decide which computer can fill your things, fill your requests, and it will decide the best computer to run it on.
Yeah. Yeah, and that's basically it. So with this, as you learn more and more shell scripting, or not if you don't need much more, you can start making these programs that will do more and more for what you do.
Yes, and
Um,
also important thing with the script, like when we now run the stuff, we run it non-interactively. So when we submitted the job, we immediately, well, we didn't see any output or anything like. So where is the like, what good is that if I don't see anything? And the reason is that Slurm will divert the output to files. So in the if we look at the count ngrams again, over here we had the output of the Python code itself, or the count.py. We use this to divert the output of the or the counting program to this file. But Slurm will also record everything that the program like prints out, and that will be saved into an output file. You can change the name of this output file as well, but use like the default is that its name is Slurm, then dash, and then the job ID. So the job that we run, the job ID, this count ngrams, we get an output file out of here. So we can later use pager like less to view what was the output over here. So we can see that like this is what the program printed. So it's the same as we would have run it interactively. We get the output over there. So often in your program you might have like program write some output into the disk, but you also want to print out okay what it is doing and if it's encountering problems and whatever, and you can later see them in these output files.
Yeah. Okay, should we give people time to work
Yes.
themselves now?
Yes.
Let's see. I will info add. When should we come back? Should we come back 5 minutes before the end time and we can briefly wrap up?
Yes. I
Um,
I will add
and
yeah.
and it may be a little bit short on time to do this, but if so, it's okay. The course will be over and then you'll have time to work on it yourself before tomorrow. We'll keep answering questions afterwards. Um, did we mention how in the Slurm history command, it showed what Slurm tracked as the resource usage, which is
Uh, we can talk about it
important.
tomorrow when in the
Okay,
monitoring,
right, yeah,
like
okay,
while we're talking about the other monitoring as well.
yeah. And I guess we will in the what's it called? In the notes, we'll add the commands that we ran, so that way you
Yes.
can copy from there. Um, yeah. Mm,
Yeah.
okay.
Let's.
Well, good luck. See you in about 20 minutes. And yeah, have fun and be happy
Yeah.
with your first Slurm jobs. This is a important day for you. I don't know, maybe I shouldn't be so philosophical. Okay, see you
Yeah.
later then.
Yeah.
Okay, bye. Hello and welcome back. So sure, a lot has happened here in these notes. Um, in the bottom, there's a place you can respond if you finished the things. That would be good to figure out. Also, we've started adding some feedback at the bottom. So just like before, this is a poll, you can add the O's in order to say if it's too fast, slow, basic, advanced, whatever, and any other feedback for us. So I had several things these from the questions I'd like to bring up, but um, it might take a bit too long to go and actually find them through the material, so I'll just say it. First, one important thing to note, once you have the batch script file to run things, now your work is reproducible. So if you save the batch scripts that you run and you come back in a month or 6 months or a year and need to run the same things again, you can basically figure out what arguments you gave and how things should work. And that's really important and shouldn't be underestimated. When you're doing this scientific work, you have to remember things for a long period of time. And if, for example, a year from now, you have to try to do something again for paper revisions or to verify the work, having these batch scripts will help you quite a lot. Next up, many of the clusters are different. So we saw something down here, for example, on the CSC computers, you need to specify the account and partition for every job you run. So on some clusters, it sort of automatically does it because the time isn't tracked by project. So this is another case where you need to find the reference for the cluster you're using and then, well, you know, copy that and translate it to what your work is doing now. Next up, there was some point a question about the output files. Where does it save the output? Okay, maybe like this here. So there's different types of output that a script can have. One is the output files that the code itself makes. And the second is what the code is printing to the screen, which is what in the Unix world is called standard output or standard error. And this standard output and standard error gets captured by Slurm and then saved to a file for your reference. So basically there's two kinds of things that happen. So your program runs, it saves the main results, and then the information about how the program itself ran. And usually it's the second one that you would look at to figure out what happened if it didn't work correctly. So yeah, these .out files like this are very, okay, I can't select. very important to look at when things go wrong, and even when things go right, just to make sure that it's going right the way you expect.
Yeah, and maybe we didn't emphasize enough in the when we wanted to get to the exercise as quickly as possible. Why are we even doing this script? So the important part is that you want to program to the computer what you want it to do. Like you want to tell it what to do, and in the case of Slurm, you want to tell the Slurm that, hey, I want you to do this thing for me, and I want you to give me the resources and do it somewhere like when I'm not watching. Like basically you're in the kitchen metaphor, you're just asking like basically you're ordering food from a a restaurant. Like you want somebody else to prepare it to you at a later date, and you will get it done
Yeah.
later. So you want to be able to tell the instructions to the computer in a way that like it understands what commands it should run when it goes to the compute node. And the output is basically the way that you can then monitor what it actually did. So in your code, you can have like print statements and stuff like that that will tell,
Yeah.
okay, I am now doing this, I'm doing that. And especially if you're running like a job in the queue, you might want to monitor the out like what it is doing, but you're not like if you submit it to the queue, you don't have an interactive session there, which is a benefit because like you can then close your laptop and close your connection. Nothing will break. It will run remotely there, but you want to monitor the output, and that's why you have the output files.
Yeah. Okay. And the last one I wanted to note, which can I find it from here, is the difference between sbatch and srun and bash directly. So sbatch will take a script file and hand it off to Slurm to run it sometime later, non-interactively. srun, when used directly from the command line, will try to run something through Slurm, but right now attached to your terminal. And it doesn't read the different sbatch comments that are inside of a shell script. And finally, if you run something with bash only, it doesn't know anything about Slurm and will just run it where you are directly. Yeah. So this is something that, well, you don't have time to go much more into depth in this now, but if you read a little bit more, you'll see us discuss this a bit more in the notes. Also, I mean, we're out of time now, and um, there is, like, this was very fast. Like we said at the beginning, it's impossible to give a course that will teach you everything about the cluster, about Linux, about the shell, about version control, about the data storage within 10 hours. So we aren't even trying to do that. Instead, we're trying to give the broad overview and show some demos and have good materials for you to follow up on just the parts you need later. Because also everyone needs different parts for their own work in the future. So not everyone can sit through weeks of courses to learn all the details. So yeah, so don't feel overwhelmed if it's overwhelming. I mean, yes, it is overwhelming. We know that, but that doesn't mean that you personally need to feel overwhelmed. It just means that you are um, you're learning things. With that being said, is there anything else we should talk about, Simo, before I go to the final notes of the day?
Yeah, I'll add that there was a good question of like, is it not possible to write the commands directly on the command line instead of writing the bash scripts? And yeah, like that's of course an option, but that requires then you
Yeah,
to have the terminal open and writing them and remembering to write them in the correct order,
yeah,
and that's like
yeah,
extra effort that I
yeah.
don't personally want to
Like,
do. So that's why
yeah,
usually you write
like,
the scripts because they tell exactly what to do. Like they tell the computer exactly what you want the computer to do, and then you can tell the computer that, hey, do this for me. and it will run those for you, run the commands that you specify for you, and you can later see that, okay, these were the commands I used to run my code. This was the actual, like, what was needed to run my code, and you
Yeah.
don't have to be there typing the commands, because the computer
Yeah.
basically, the queue basically types those commands for you. Like when it
Yeah.
gets the
Like,
job reservation, it will type those commands in the Slurm script into the terminal, and it will run
yeah.
those.
Yeah. Like, for example, there have been times I needed to use the cluster. I had one thing I needed to run that uses 200 megabyte or 200 gigabytes of memory. So there I'll go and I'll run it direct from the terminal. I'll load the data, do a quick calculation, and be done with it because it's only a single thing. But when I need to do something 100 times because I have 100 different data files, then I want to make scripts for it. So yeah, um, it's a what's it called? Spectrum of ways you use things. Um, yeah. So for tomorrow, um, we covered what was on the schedule. And if you look on the schedule, there's the same stuff, links to it in tutorial format that has more information. Yeah. So you can read that and catch up, learn more, whatever. Um, we know you might need more time for the exercises, so keep working on it later or for the rest of the day today, tomorrow, whatever. Maybe we can even make a Zoom session in the morning to review things for those in Finland. Or ask your colleagues, your friends, whoever for help. I mean, a lot of the things here, it's hard to do by yourself, but if you have another pair of eyes who knows things looking at it with you, they can help you quite a bit. So find that person who will help you. And what we did today is needed in order to continue tomorrow. But also that means what we do tomorrow will help to review what we did today. So if it doesn't completely make sense now, it's okay. Take it for the day, digest it a bit, think about it. When you come back tomorrow, we'll start again from the beginning. Well, beginning, like, you know, what's it called? You'll see new examples starting from the beginning. And that may help to put things into perspective and understand the power of what we do here. For example, we'll take the Gutenberg books and run it for every book in parallel, and it will be really easy and very fast. And please do fill out the feedback poll here. Um, there is, if you don't tell us what went wrong, it's hard to improve it for later. I'm glad that things are mostly looking okay here. And yeah, we realized that we need better instructions for what we do before the lecture. So we've recently created a new example. Before, our example was calculating pi, now it's Gutenberg, and all the written material isn't updated for it. So that makes it just a little bit, well,
Yeah, yeah.
yeah, we
There's
didn't have a
always
good thing to point you to.
this conundrum with these courses that like if the example is way too of a toy example, it doesn't reflect the real situation, and if it's closer to the real situation, everything becomes it can become more complicated, and we try to adapt everything like all the time. But yeah, sometimes especially when we are doing like a switch from one example to another, like the material not doesn't necessarily follow immediately. So yeah, that's unfortunate. We'll definitely improve that in the next iteration.
Yeah, should we just end now? We will keep, there's a question somewhere up above. Do we have homework for tomorrow? So the homework is just to try what we did, read stuff. I mean, basically the homework is to keep reading and trying stuff until you feel comfortable with it. Um, there's no strict homework like, you're not going to be graded or whatever. You're only here for your own benefit. And don't forget, if you're not coming back a future day, once you're done with this course, come to our garage if you're at Aalto and ask for help. We're here to help you to see you through all of these steps. You're not alone. Yeah, okay. Should we go then?
Yep.
Okay.
Yep.
See
See you tomorrow.
you tomorrow, same time. I just heard Saul in chat that yes, we can have a Zoom session before the day starts tomorrow. So if you're one of the Finland people that has access to the Zoom, stay tuned for an email to come and get help then. Okay, now let's go for real. Okay, bye.
Bye.